Hi, my name's Mark and I'm going to help you contribute to the Science Scribbler Key2Cat project here on Zooniverse. So if you've been doing any Zooniverse projects in the past or any Science Scribbler projects in the past, then you'll probably know most of what we need to do here. But we're going to run through a few things anyway if you're new or just in case you want a refresher. So to begin with, the first thing that's really useful to do is to take a quick look at the About page that you can find here on the web page. The reason this is useful is because it tells you all about the research we're doing, but also all about the team who's involved, who does all the actual work in this project, and it gives you quite a good overview of all of the things, including some frequently asked questions and various information. But let's head to the research again. Now, this particular project is really interesting for Science Scribbler because most of the work we've done previously has been about biological samples, and this is the first one we've done on a materials sample. And to do that, we've basically partnered up with a few different groups. So we have the University of Oxford's Material Science Group, we have the EPSIC Image Analysis Group, and we have the Rosalind Franklin Institute on the Harwell campus. And this particular research is all about looking at nanoparticles, specifically catalysts. And catalysts are very well explained here, but actually the key thing about them is that they accelerate existing processes. So if you want to have a chemical reaction and you want to make it run faster or maybe run with a lower amount of energy use, then that's where catalysts make a really big impact. And that can help with a lot of the things that we're worried about at the moment with the climate, because reducing our energy consumption in a lot of these manufacturing processes is really important. Now, one of the reasons that nanoparticles are really interesting is because often the bit of a catalyst that does all the hard work is on the outside of the catalyst. And if you imagine taking an apple, you've got all of the outside area of that apple, but all of the inside is kind of wasted, right? None of that's reactive. And if it's all made of something that's reasonably expensive, well, that means you've got a lot of wasted material in the middle. So the way to expose more of that material to the outside would be to cut the apple in half. Then you've got all of the area you had on the outside before, plus these inside surfaces that you've just made available. And if you kind of cut it in half again and again and again, every time you're increasing the surface area, but you've still got the same amount of apple that you started with. And this is kind of what happens with nanoparticles. If you were to imagine just keeping on cutting that apple up all the way until you get down to like a very, very, very fine powder, that's exactly what nanoparticles are. Lots of surface area, the reacting bit, very, very small internal area, the expensive bit. And so we're particularly interested in these because of the properties for these catalysts. But if we're making any sort of catalyst or we want to test it, one of the key things we want to do is look at it. And that's where the instruments at EPSIC come in, because they enable us to use very high power electron microscopes to actually look at what these individual catalyst particles look like. And you can see a bunch of them highlighted on this image here. And by understanding what they look like and where they are, how many of them there are, what sizes they are, we can understand how good the process we're using is, and therefore how to optimize that and get the best out of it. Now, actually in this case it's interesting because traditionally, especially with image analysis is hard, but there's been massive transformational steps happening over the last few years in artificial intelligence and things like this that will automatically do a lot of amazing things for us. However, in this case, because we don't have that much data, artificial intelligence works brilliantly where you have loads and loads of data. And you'll probably, if you've been to any of the Science Scribbler projects before, there's a lot of what we try to do with the data that you provide us is to use it to train artificial intelligence systems. But if we don't have that data in the first place, often these techniques don't work as well as we hope. And so here's a really nice example. Actually, the AI technique is picking out quite a lot of the clusters, but it's also missing some. And you can see these patches here where the image becomes a little bit difficult. You can just about see the clusters there by eye, but the algorithm can't pick them up. And so that's where you step in, because what we're interested in doing here is identifying all of the different nanoparticles, but also the clusters of nanoparticles, and that's the other thing the artificial intelligence at the moment doesn't get particularly right. So do take a look at the About page. It explains everything that I've just said in a lot more detail. The only thing I'm going to highlight here is that we actually have two specific systems that we're interested in. One of them is these gold nanoparticles on germanium, and that's described as AUGE in most of the definitions. And the other one is palladium nanoparticles on carbon, and that's PDC. And so you may well see these. The reason I highlight it is because later on there's places where they look very different, or they're similar but they do look different, and so you may want to know which one you're looking at before checking out information. So let's get started. Let's go back into Classify and let's see the project that we've got. This is a great one to go with to begin with because it shows us a couple of the things that we're interested in. So the first thing is, I've just gone on here because I've already looked at the tutorial, but there is a tutorial that goes through and very clearly describes exactly what you need to do. There's a few steps. It clearly highlights in examples and shows you how to go through this process and exactly what you need to do at each step. If you need to go back to the tutorial, just go there. And if you find that you're a little bit confused about what's going on, then it's always worth just nipping back to that. So what we are going to do though is, you can see here, this is the gold germanium system. And so, and there's some nice little details here. So yeah, the whole width of this image, including the grey bits, is 56 nanometers. And I think you can actually start, if you look at the little spots in here, you can start to see the atoms that are actually going on. It's an amazingly powerful imaging technique. It's very, very good. But what we're interested in is identifying the clusters. And you can see the individual nanoparticles, and you can see three very clearly there. So we simply activate the marking tool and we drop right in the middle, if you can, of where the particles are, these places. Now, if you get one wrong, there's a little X at the top that you can just click, and if you pick up one, you can delete those quite nicely. If you drop one on in the wrong place, then you can see a little hand appears and you can just click and drag that back into the right place. The closer to the middle, the easier the rest of our processing is. So do try to get them as close to the middle as you can, but it's not critical that they're perfect. So you can drop these particles on, and once you've got everything identified, then you can say next. There's a couple of other things that you should be aware of. You can see here this particle is kind of cut off at the edge and it goes into this grey area. Now this grey area it's the edge of the image that we're imaging. You'll sometimes see these. Just ignore them. They're just an artifact of the way that we cut up the data to present it to you in a nice way. You may see grey on just the top or just the right or just the left or just the bottom or one of the corners like this. This is kind of an extreme area. If you do see the particle go off the edge into the grey or off the edge of the image itself, just try to put it in the middle of where you think that particle would be, remembering that they're roughly round. And once you're complete, you can click on the Done button. If you see something particularly interesting that you'd like to comment on, you can click on the Done and Talk button, and then it goes to a specific talk page that allows you to discuss that particular image. Okay. So we'll just click Done here, and then it takes you to the next image. Now this one's got possibly something that's reasonably nice for us to look at clusters with. So I'm going to start this process with, I'm going to pop one here, and one there, and one there, one there, one there, one there, and one there. And then this one here, it looks like there may be two blobs clustered together. So I'm going to put 2 marks in it. Once I've done this, I'm going to say done, go to the next one. Perfect. I can't see any clusters in here, so we just say done. And this is essentially how you can keep on going. Now, if you're a little bit unsure of anything, on the right hand side here is the field guide. And the field guide has got a whole load of different types of things that you may see. So for example, this is what the nanoparticles look like, and it shows you how you should mark them. There's also what the clusters look like, and again, how you should mark them. This is a better example than the one that I just had, where you can see put a blob in the middle of each of the clusters. and into big clusters, how you identify them as well. You can also see some of the common artifacts. So in fact, here we go. This is this little blobby bit here. And in fact, we can see that in this image here. So this is quite nice to say, okay, well, actually, this isn't a whole bunch of little nanoparticles here. This is one of the artifacts that sometimes arises from either the data collection or the instrument itself. So, and then the final one here is, oh, sorry, I missed the clips, which is what you saw here, these partial clips, so that you can ignore those. And you can see this has the gold germanium and the palladium carbon as two different things, and you can see actually that these do look different. The palladium carbon ones are a little bit harder to see, and so there's some different ones. So when you're using the field guide, do remember to check which one of your things you're looking at. But that's it. And then you can just keep working your way through, targeting all of these things, and go for as long as you want to, and come back and do some more later if you can. Everything that you do is super useful to us. And if we look back at the kind of, if we go back to here, you can sort of see at the top, there's various statistics on how many volunteers are going and how far through this process we are. Now, the reason there's lots of data here is because we've got a lot of these electron microscope images that we've broken up into lots of small patches to make it a bit easier for you to process individually. Once this set of processing is complete, do keep an eye out here though, because we have these large number of sets that we're interested in and we're trying to get through them. But as soon as we have them completed, what we're then going to do is do a second round of this process, very similar to what we do in the other Science Scribbler projects, where we clean up the data. And that's because sometimes it is very difficult to identify these. Sometimes we get some incorrect identifications, and it's really useful for everybody to go through the data and to say, yes, that's definitely a particle. No, that's not. This is a cluster. This isn't. It's incredibly useful for us to then be able to classify and process the data, and indeed train artificial intelligence systems in the future to hopefully do this for us. So again, I'd like to say thank you incredibly for helping out or wanting to help with this project. As I say, it will make a massive difference to the research the team is doing in the Key2Cat project. Thank you very much for your time. And if you have any questions, I'm sure you can just drop them in the comments here, or better, use the talk boards that are associated with this project, which enable you to do anything you want in terms of ask about help, talk about the project, see if you have any specific questions for the researchers, so that you can kind of, if you're just interested in any of the science that's going on, the researchers will love to talk about that as well. Thank you very much for your time, and good luck.